Now that we've practiced solving an inequality in the above problem, we're going to look at one in particular when there's a fraction involved, still following our same process. So solve the following inequality and graph on the number line. So I'm going to first split up my inequality from the left side and then also on the right side. I know that I'm going to use GEMDAS still to identify the order that I'm going to solve, particularly since it's backwards, to identify what the variable a is. So I'm looking for adding and subtracting first. I see plus 5. I know the opposite of a plus 5 is a minus 5. And I'm left with 2/3 a is greater than or equal to. Now, a negative 4 minus a 5, I know that I can write that out like this. Negative 4 minus a 5. I also know that I can use KCF to change it to adding the opposite, and it becomes negative 4 plus negative 5. And when we look at our tic-tac-toe chart, I know that adding the integers with the same sign and then keeping the sign on the answer would give us a negative 9. Well, if you actually just quickly look at how it is written here on our problem, I see that they have the same sign, so I can actually just quickly add them together. So a negative 4 plus another negative 5 would get us a negative 9, just visually seeing that they both have a negative. So that's one kind of trick or tool to look for. So you don't always have to use KCF and then go back and get the same answer. You could just see that two negatives, we're going to add and keep the sign. Okay, now that we have adding and subtracting done, let's look for multiplying and dividing. Well, we know that it's 2/3 times a, so the opposite or the inverse is to divide by 2/3. And the reason we're looking at this problem is because I know 2/3 divided by 2/3 get 1a, and it's greater than or equal to. But then this fraction over here looks a little funky, so let's go ahead and rewrite it. Negative 9, let me write it over here. Negative 9 divided by 2/3. Now, it's been a while since we've looked at dividing fractions, but we also use keep, change, flip to write it to the multiplicative inverse, or the opposite of division is multiplication. And we multiply by the reciprocal, right? Or we flip the fraction over. So we're going to look at what that reciprocal is here in a second. So we keep the negative 9, we change division to multiplication, and then we flip 2/3 to its reciprocal, or 3/2. So the reciprocal of 2/3 is 3/2, right? We just flip the fraction over. Okay. So I wanted to review that before we multiplied our fractions across like normal. And then I see negative 9 times 3 would be a negative 27, and 1 times 2 is 2. Then I know that I can simplify that using bow tie, bottom out, top in. So 2 is on the outside and 27 is on the inside. 3 times 2 is 6. Let's add our decimal and our 0. 2 goes into 10 5 times. So our answer is negative 13.5. So let's put that into our inequality. Oops. So then our final answer would be a is greater than or equal to negative 13.5. But remember, we talked about how inequalities have multiple solutions in them. So I'm going to actually have negative 14 and negative 12. I know, actually, no, negative 13, I'm sorry. So this would be negative 13.5. And so I could have numbered it however I wanted, going by 10s, going by 2s, going by 1s, right? You can always number it however you want. I'm just showing different ways to number it here. And so now that we have negative 13.5, we need to ask ourselves, does this include negative 13.5 as a solution to our inequality? Is negative 13.5 greater than or equal to negative 13.5? Well, since it's equal to, and we know that that's that bar underneath the greater than sign, then we know that's true, and we will shade in the circle above negative 13.5. And now, where are all the numbers that are greater than negative 13.5? Well, I see that these numbers are going in the positive direction. So we're going to draw our arrow going to the right, or the greater than side of our number line. So this is our inequality, the first part of our answer. And here is our number line showing the second part of our answer visually on the number line. Alrighty, so I just wanted to show what happens when there's a fraction in front of the variable. You're going to practice some more on your own.